Hey everybody, for the last session we're going to be talking about plate tectonics in Arizona, the local stuff. So first, we talk about three geologic Arizonas. So does the landscape and the environment look the same in a place like Phoenix as it does in Flagstaff? And what about for Prescott? Does it look the same as either of those two? So when we talk about this, we're dividing Arizona into three broad regions. You have the Basin Range province for the south and southwest, and Phoenix and Tucson. You have this transitional zone, which is sort of halfway in between the Basin Range province and the Colorado Plateau up in the northeast. And we call this the transition zone in the middle, where you have Prescott. Uh, so we divide it into these three areas, and each one has a sort of its own history and its own explanation for why the things there look the way that they do. And plate tectonics serves to help us explain these histories. So, southwest portion in the Basin Range province. Uh, this is a site where the crust of the Earth, the plate, is being extended. It's being pulled apart. So after the San Andreas Fault activates, it releases a tremendous amount of pressure that was on this part of the United States. And when it releases that pressure, that part of the United States begins to extend. Right? If we were looking at it from the side and we see it extending outward, what we would see is a series of lows, which are the basins, and alternating highs, which are our mountain ranges. And here's another view of it, sort of the bird's eye view. We talk about extension. This is that pulling apart. So everything from the Wasatch Mountains to the Sierra Nevadas, California, is being pulled apart by these extensional forces. Uh, Here we have talks about the release of compression. We're taking pressure off as a result of strike slip motion. That's the side to side motion. And it's important to know what the sort of steps were behind this part of the United States forming. So the first part that we're going to worry about is the activation of San Andreas Fault. It's that side by side slipping fault. As it starts to come into place, sliding, it releases pressure and causes the plate to stretch out and get thinner as it extends. As it does this, as it gets pulled apart, it fractures, it breaks into pieces. Some of those pieces move up, other pieces move down. And one of these actually has a nice little way to show us. Let's see if we can get this. Here we go. And we'll play the video here. Just going to go through it real quick. I will go ahead and do the annotations, I think, myself. Right, so we're talking about extension and deformation. We have our alternating basins and ranges. Basins are lows and ranges are highs. This is what it looks like. And this is mostly concentrated here in this region. You can see including a bit of Arizona. This is our direction of motion outward. And this is what it looks like before extension. Notice how wide it is. And then as the plate stretches, hot mantle rises up beneath it, causes it to further fracture and spread outward. And it gets pushed outward, outward, and outward, and it develops these fractures to help accommodate this motion in order to help it to spread out. The plate rises, some of it, it thins, all of it, and we get a series of mountains and valleys. And if this goes on a little more over millions and millions of years, then what we get is something that looks like this. So we have our width before, and then our width after is up to 30% more. We have stretched out this part of the world by a full 30%. Thought that was maybe a little bit more helpful than my little hand motions. Don't tell me that though. So if we're back here, this is part of our tectonic cycle. We have our entire, if you remember from our first unit, our hydrologic cycle, and then the rock cycle, which overlaps with our tectonic cycle. This is what we have been covering in this unit. Earth is hot, the interior, space is cold, and over time we are losing our heat to space. And the way that we lose that heat is through plate tectonics. It's through this process. Uh, and because this question does come up, uh, this is some idea of what we think the world might look like in 250 million years, 250 million years into the future. So you can see that we've closed the Atlantic Ocean here between North America, South America, and Africa. We've also closed uh, everything here with Europe. Europe and Asia have sort of rotated downward and slid together. And Australia has finally become a part of Antarctica. Wish the people there the best. Okay, what are our big ideas? What are the things that you would need to focus on? So, we talk about plate tectonics. Why did this idea come up in the first place? What is it there to explain? And what are our proofs, our measurements we have nowadays, which make us very confident that this is what's happening? Uh, what is mantle convection? So, what is mantle convection, period? And also, what is it driving? Why do we even talk about mantle convection? What is this relation to the other ideas? Are types of boundaries. So, divergent boundaries divide, convergence collide, and transform boundaries slide. Uh, Finally, Basal range formation. What happened to the part of Arizona that we live in? Thanks.